I'm going to supplement what we covered the other day about symmetry. I think I made the point clear that when you have x squared, let's take an example, y is equal to x squared. If you draw that graph, later on we're going to find that it's always going to give us that U-shaped curve. So we look at this, and this is symmetric to the y-axis. In other words, the y-axis splits it in half. The rule is when you replace an x with a minus x and the y stays the same, then it is symmetric with respect to the y-axis. The easiest way to look at it is just replace the x with a minus x, but we know that a negative squared is positive. So the original equation and the equation that we have now are the same. It didn't change. So that makes it y-axis symmetry. Now, if you have x is equal to y squared, then this time, if you replace the y with a minus y, the two equations stay the same. Well, when you look at it from a graph, the x is equal to y squared is simply a sideways parabola. And this time you have x-axis symmetry. So what happens, and we looked at this the other day, the circle. Take a simple example. Let's draw us a circle. And this circle is going to have a radius of 5. And we're going to cover that probably in the next lesson. But this thing has y-axis symmetry, it has x-axis symmetry, but it also has origin symmetry. Now, to find origin symmetry, you replace the x with a minus x, and you replace the y with a minus y. And when you do that, you get x squared plus y squared is 25. So the two equations are the same. And when you can replace the x and the y both with a negative, and you still get the same equation, you also have origin symmetry. Of course, compass may tell you that it's all, in other words, that it's symmetric to the x, it's symmetric to the y, and it's symmetric to the origin. An interesting thing, though, you don't have to have x squared and y squared to have origin symmetry. Let's take a simple equation. Y is equal to x cubed. Now, you replace the y with a minus y. You replace the x with a minus x. But a negative cubed stays negative. Now we got negative on both sides of the equation. So we multiply both sides by -1. And lo and behold, we end up with the same equation that we had to start with. So you can have origin symmetry when you have an odd function. Now, the interesting thing is when you draw the graph of y is equal to x cubed, you're going to have a graph that looks like this. Notice when x is 1, y is 1. When x is 2, y is 8. And when x is -1, y is -1. And when x is -2, y is -8. Now, origin symmetry says that you take any corresponding points on the graph and you find their midpoint, and it's going to be the origin. So do it. 1 plus a -1 is 0. 0 divided by 2 is 0. The same thing for the y. So the origin is the midpoint. Take the 2, 8 and the -2, -8, and you get the same thing. You get 0, 0 for your point. So this is the idea of origin symmetry. Now, look at this one. If you replace the y with a minus y, the equation stays the same. But if you replace the x with a minus x, the equation changes because you have minus x squared, 2 times minus x plus y squared is 3. So this is going to give me x squared plus 2x plus y squared is 3. So I don't have the same equation because my original equation was x squared minus 2x, and now I have x squared plus 2x. But remember what we said, we could replace the y with a minus y and it didn't change. So that means that it's supposed to have x-axis symmetry. Now this is a type equation that we're going to draw the graph of a little bit later on. I'm not going to take the time here to show you how I'm doctoring it up, but I'm just going to doctor it up so I can get the correct graph. And we'll learn why we have that one later on. Okay, what's happened here, this is still a circle because it's x squared and y squared. But this time, the center of that circle moves to the point 1, 0. It's going to have a radius of 2. So that circle is going to look something like that. Now, you notice that it's off to the right, so it doesn't have y-axis symmetry. But look at it. It does have x-axis symmetry because if you just folded it over, then the top would fold onto the bottom. So we can have symmetry with one axis and not with the other axis. There's one other thing that I think I left off on that last lesson that we're going to take a look at. And it says, and course compass gives you this problem. He says, draw a line using the slope and the y-intercept. Well, let's take an easy one to fool with. Y is equal to 2/3 x plus 6. Okay. Just looking at the equation, we know two things about it. Number one, we know that the slope is 2/3. And number two, we know the y-intercept is 6. So when x is 0, then y is going to be 6. So if I say that this point right here is my 0, 6, and we said the slope is the rise divided by the run. Now, I always do the run first. And my run is 3. So I'm going to come over here 3 units, and then I'm going to do a rise of 2. So I'm at the new point 3 and 8. And then we draw our graph. So we have drawn the graph by locating the y-intercept and using the slope. You can check yourself out. Let x be 3 in this equation. Well, 2/3 times 3 is 2, and 2 plus 6 gives me that same point of 8. Also, let's emphasize the idea of a negative slope. Suppose that I have negative 3/4 x plus 12. All right, so my y-intercept is 0, 12. Now my run is 4. And my rise is 3. But notice, when you have a negative rise, that means you come down instead of going up. So this new point on the graph here then is going to be the point we had a run of 4. So it's going to be out 4. And then it's going to be down 3 from 12, which is 9. Again, you can check yourself. 3/4 times 4 gives me negative 3. And negative 3 plus 12 gives me this 9. I thought we needed to just clear that up a little bit. You might want to look at this before you do that section in the homework.